Chapter 9 begins quadratic equations, and our first step will be solving quadratic equations by finding square roots. Goal 1 is evaluating what a square root is. You know how to find a square of a number. For instance, the square of 3 is 3 squared, or 3 times 3, which is 9. And the square of negative 3 is also 9, because negative times a negative is a positive. So negative 3 times negative 3 would still be 9. In this lesson, you will study the reverse problem, finding the square root when given the number. The symbol plus or minus is read as plus or minus and refers to both the positive square root and the negative square root. 0 has only one square root, and that would be 0. 0 times 0 is the only way to get to 0. Negative numbers have no real square roots, because the square of every real number is either positive or 0. Because when you square two negatives, negative times negative, you will end up with a positive. So here's a couple of examples for us to get started with. It says evaluate the expression, and our first expression is 64. The radican is the symbol here for square root, and maybe do it this way to see it easier. And then we call the radical symbol is the symbol here. So this is the radican underneath the symbol, and this is the radical symbol. So if we start things out, we're going to look at the square root of 64. Now, because we know that 8 times 8 is 64, we can say that the square root of 64 is going to be 8. The next expression that we will look at is the square root of 54, but you'll notice that there is a negative sign outside of the radican symbol. So that means, remember, we can also write a negative sign as opposite. So the opposite of the square root of 64. So again, 8 times 8 equals 64, but we want it to be the opposite, or the negative of that. So the answer to letter B would be a negative 8. Letter C, we spoke of just a minute ago, the square root of 0. That has to be 0. It's the only way to get to 0, or the only perfect square of 0 would be 0 times 0. Letter D, this time we have a new symbol, the plus or minus that we talked about in the intro. The first step when you have a decimal is to think of that number without the decimal. So we're going to just think of 25. 25 has a perfect root of 5. 5 times 5 equals 25. However, in the decimal number, we have two place values behind the decimal point. And in 0.5, we could say that that's two place values, because 0.5 times another 0.5 would be one place value, and then we do that place value again. So that is how I got to the 0.25. And then our last one, we see that the negative sign is inside of the radican symbol. And so what times itself would give you negative 4? That would be an undefined, because nothing times itself can equal a negative sign. You can get to 0, or they're going to be positive, but you cannot have a negative. Moving on to example 2, we're going to talk about perfect squares. And numbers whose square roots are integers or quotients of integers are called perfect squares. The square roots of numbers that are not perfect squares must be written using the radical symbol or approximated. These numbers are part of the set of irrational numbers. An irrational number is a number that cannot be written as the quotient or a fraction of two integers. So if we start with number 1, we have again a negative symbol on the outside, and then we have the square root of 121. We talked about the square roots that you should have memorized, and we said if we knew 11 times 11, 11 times 11 is 121, our answer would be 11, and again put your negative sign back because that was outside of the radican. Now, the next two we also should know by heart. Again, it's a decimal, so we're going to pretend the decimal's not there for a minute. So we would have 144. One of our perfect roots is that 12 times 12 is 144. That's one that we have memorized. And we need two decimal points again. So if we put the point at the 10th spot, we have 1.2, 1.2. Again, I have 2 dinks, or 2 place values, after the decimal point. And when I would multiply those out, I would have the 2 dinks in that answer. Going with that rule, 0.09, so we look at just the number 9. It's a perfect square, 3. And we need, again, 2 place values. So we're going to make that 0.3 times 0.3. 2 dinks there in our multiplication, which then would give us 0.09. So the square root of 0.09 is 0.3. Our last one is the square root of 7. The square root of 7 does not have a perfect square. Now in your books on page 811, and this is also noted in the book on the page that we're on. Oh shoot, I should have taken us right to 811. All right, in the book on page 811, and I can see that my recording, I'm going to have to pause it because we do not have the full screen here. Maybe I can just show you the second part of this. You can see that there's 3 columns, the number, the square, and the square root. Now, if you look at the numbers, it's the ones that we said we should have memorized, is 144. That would be the square root of 12, and that's a perfect square. That is the last perfect square in that on that page. To find a perfect square, you would look at the last column, because the last column said the square root, and any of the numbers that are listed that have zeros after the decimal point and only zeros are perfect squares. So again, going back down here, 12 is a perfect square of 144. Going up the column here, the next one I get to is 11. 11 is a perfect square of 121. We just had that in that in that example. And then the next one that I get would be in the next column, and it would be 100. This one stops at the 101 because the square root of 100 is 10. So you might want to remember that or put that on the top of the page for your assignment. Sorry about that. Moving back to our lesson, another way they had mentioned was you could approximate. So if you did not have the perfect square root table in your book handy, you could try to approximate. So we're looking at what's the square root of 7. I'm going to look at the 2 numbers, the number less than and the number greater than 7, that have perfect roots. So those 2 numbers are going to be 4 and 9. Now 4 is less than 7 and 9 is greater than 7. Both of these numbers have perfect roots. Perfect root of 4 is 2. The perfect root of 9 is 3. I can say that 7 is closer to the number 9. So if I had to approximate a square root, I would say that square root is 3. Now, if I had to work out the multiplication on my own, then I would start at some numbers that are a little bit closer to 3 and see if I could get a decimal. The other way that you can do this is just by simply using a calculator. So if I was going to use a calculator and I want to find the square root of 7, I'm going to get my square root symbol and then 7 and hit equal. Oops, sorry. This one I guess is a little bit different. I'm going to get 7 square root, and then I would get 2.645, and it's a standard rule that you would go ahead and you would round to the 100th. Round to the 100th. So if we were approximating, we could come close to that as well. Back to our lesson then, we see that 2.65 times 2.65 is going to be that perfect root. Moving along, so you can do it by calculator or you can do it by approximation, or if you have a chart handy with perfect squares on it. So it says a radical expression involves square roots or radicals. If this symbol, and this is the symbol we were talking about before, plus or minus, precedes a radical, the expression represents 2 different numbers, as in example 4, which we will get to. The square root symbol is a grouping symbol. Operations inside the radical symbol must be performed before the square root is evaluated. So here's our question. Evaluate what the square root of b squared minus 4ac is. The first thing that we're going to do is we're going to substitute the values in. So a is going to be 1, b is going to be negative 2, and c is going to be negative 3. When I go to substitute those in, I get my new equation, which is negative 2 squared minus 4 times 1 times negative 3. Now, as they said, the expression underneath could be thought of as it's in parentheses. So we're going to go ahead and we're going to solve that first. So I need to simplify. I could simplify the multiplication here, and I can simplify the exponents. When I simplify the first time, I get negative 2 squared is 4, and 4 times 1 times negative 3 is going to, negative 4 times 1 times negative 3 is going to be a positive 12. I can simplify one more time now. I got all my symbols out of there, and I have the square root of 16. We know the square root of 16 is a perfect square, so we're going to say the answer there would be 4. Again, we have, I think maybe my slides are in the wrong place, so I'm going to go ahead and I'm going to move on past this. Oh no, we did not practice the evaluating with a calculator yet. So if you're going to do an evaluation with a calculator that has an expression in it, you're going to do the parentheses first because we said we want to group this expression together. So if you want to keep something together, which we want the whole numerator together, we want to make sure that we put parentheses around the numerator. So we're going to do 1, we're going to add 2, and then multiply by the square root of 3. Again, on the calculator I showed you, you had to hit the number and then square root. Your calculator might be a little bit different. And then you see we put the parentheses back in. Then we can go ahead and say divide by 4, and when you hit enter, you will get this an answer similar to this one, depending on how large your display was. Now, because we said it could be a positive or a negative, the next time we do this, we're going to do it, we're going to use the negative symbol for our radical expression. So we would say parentheses 1, and this time it's plus or minus, so we're going to use the minus or the negative, minus 2 times 3, which is the square root, and put our parentheses in there and divide by 4. And this is the answer to the expression if we were talking about it as a negative number. We are to goal 2 now, and so now we can introduce the quadratic equation. A quadratic equation is an equation that can be written in the following standard form. And that would be that our first term, we're used to the a plus the b plus the c, but we're going to go ahead and we're going to do our first term is ax squared. Our next term is just going to be a simple variable, x, and our last term is going to just be a single number or constant term, so we will not have a variable in combination with it. In standard form, a is also called the leading coefficient. So when b is equals 0, this equation becomes ax squared plus c, because the term bx would be eliminated, because if b is 0, 0 times anything is 0, so that's how that term is eliminated. To solve quadratic equations, you need to isolate your x squared by itself, and then you can solve for x. So our variable expression that we're looking for is x. Let's go ahead and see how this would work. So our first expression is simply x squared equals 4. This is going to have two solutions because it is a square root. And when I look at those two solutions, sorry about that, when I look at those solutions, I would say that you could do x is a positive 2 or x is a negative 2. Because if I square 2, I get 2 times 2, which equals 4. But also, if I square a negative 2 times negative, I get a positive 4. So the square root, and the way that I would write this on a piece of paper is I want to get x by itself, just like I have always done in algebra. So instead of multiplying or dividing both sides, I'm going to use the radical symbol to show you I want the square roots of both sides. So the square root of this would end up just giving me x. And then when I find the square root of 4, I would find out that that is 2. 2 times 2, and it could be the positive or the negative 2. Moving on to the next one, we have the x squared equals 5. In this expression, it also has two solutions. However, when I'm working this one out, when I'm working this one out, I would want to know the square root of 5, and it's not one that has a perfect square, so it could be the positive or the negative of the square root of 5. We can write this as one answer if we use the positive negative symbol and put it in front of our radican sign. Letter C is x squared equals 0, and we said the only way to use one term times itself to get to 0 would be if that answer only had one solution, that solution would be that x equals 0. 0 times 0 is the only way to get to 0 with the same multiplicative term. Now when we get to the next one, we have x squared equals a negative 1. Again, we don't want to know what x squared is, we want to know what x is. So I'm going to square root that side. When I do that, I need to square root, oh, that one got a little carried away, square root the other side, which is the square root of negative 1. Now, we have to try to find what we could multiply by itself to get to a negative 1. And because there is no number no number when multiplied by itself that would give you a negative, because a negative times a negative would be a positive, this particular question has no real solution. So the square root of a negative cannot be solved if the negative sign is on the inside, and that is the only term. So this time we're going to get an equation, not just an expression, an equation here. So we're going to have to remember all of our algebra rules. So the rule for algebra is we want to figure out how to get our variable by itself. The first thing we're going to do is we're going to get rid of the constant term and get it with the other one. So we would add 48 to each side, and when I add 48 to each side, I would end up getting that 3x squared equals 48. My next step would be, I still have a coefficient, so let's divide each side by 3. When I do such a thing, when I do this, and I have my tool, my goodness, when I divide each side by 3, I will end up with x squared equals 16. Still haven't got that single variable, I still have a squared variable. So, you guessed it, the next step would be you need to find the square root of each side. When I'm finding the square root of each side, I would find x equals the square root of a positive or negative 16. Now, the only thing that is left to do is to see if that's a perfect square. It is. 16 is a perfect square. So when we are doing this, we would find out that that could be a positive. Oops, looks like I didn't write that one down. Okay, we would get a positive or a negative 4. Because 4 squared would be 16. But also, when I square a negative 4 times negative 4 also will result in a 16. To check your answer, you always want to square your answer and see if you come up with the solution that is inside the radican sign. I believe we have one more example, and this is called the falling object model. You will use this a lot in science, and usually the formula is repeated for you. So when an object is dropped, the speed with which it falls continues to increase. As it gets closer and closer to the ground, it's going faster and faster. Ignoring air resistance, its height can be approximated by the falling object model. So we're going to try to figure out what the height is, and we're going to use the formula negative 16t squared plus 6. Here, h is measured in feet, t is the number of seconds the object has fallen, and s we're going to use to represent the initial height from which the object was dropped. The object's increase in speed is due to the Earth's gravitational pull. So on a planet whose gravitational pull is different from Earth, the factor negative 16 would be replaced with a different by another constant. So let's move on and see if we can figure this out. So an engineering student is in an egg dropping contest. The goal is to create a container for an egg so it can be dropped from the height of 32 feet without breaking the egg. Now, why you would be up 32 feet and have an egg in your hand that you'd be worried about dropping, I'm not sure. But to the nearest tenth of a second, about how long will it take for the egg's container to hit the ground? And we're going to assume that there is no resistance. So the first method we can do is we're going to go ahead and we're going to, plug in to our formula. And we're going to say the time, if the time was 0, the height needed to be at 32. If the time is 0.5, it would go to 28. And again, all we're doing is putting in, substituting our time. So 1.2, we'd substitute time in here. We'd square 1.2, multiply it by a negative 16, and then combine those to figure out our answer of rounding 8.96. The method 2 is more working it out. Again, we use that same formula or model, and we substitute in what we know. So we know at 0, and again 0 feet, we know that one, it would follow that model. Now it asks us, what about if the height is 32? So if it's 32, we need to subtract 32 from both sides, giving us negative 32 equals your negative 16t squared. Now I have just my, I have one variable over here, so I need to divide both sides by a negative 16 to get rid of my coefficient, and that would leave me with 2. I'm still at a t squared, however, and I don't want to know t squared, I want to know t. So I need to square root both sides, giving me t is equal to the square root of 2. Now we're going to go ahead and we have a positive square root. We're going to use a calculator so that we can get our answers in a decimal value. In answering question, they want a value, and a value could not just be expressed by the square root of 2. And that finishes our 9.1.